So I'm going to go through these 5 questions and 2 that have to deal with transferring from standard form to vertex form and finding all the parts of it. This is what we did in class today. So in case you either missed it or need a refresher, you have these problems. So here's the 5 questions I'm going to go through. I'm going to give you a minute if you want to write them down. That way you can try them and then continue playing for the answers. Okay, and if you need more time, obviously you can pause, go back, and write these down to try them first. So the first thing you want to do is you have to get your variables alone. They have to be the only thing on that side of the equation. So in number 1, I'm going to start by subtracting the 4. In doing so, now I have my x's grouped together, and I can start completing the square. In order to complete the square, we are going to use b over 2 and square it, and that's going to help us be able to factor it into a perfect square using the shortcut of whatever b over 2 is, added or subtracted with your variable. So in this case, my b is an x. So I'm going to take 4 divided by 2 and square it. That is 2 squared, which is 4. Okay. I'm just going to scoot that over a bit so it doesn't encroach on number 3. There we go. Once I get that 4, I'm going to then add it to both sides. I'm forcing that square to happen. Because I'm forcing a square, I can do the shortcut over here. That is going to be x plus 2, that was my b divided by 2, squared equals 36. From this point, it is just your normal solving by square root method that we've done previously. You square root both sides to get the insides to drop down. Remember, when you square root, it's plus or minus. So this is 6 in that case. And then we just continue solving, get x completely by itself. So I have x equals -2 plus or minus 6. Because these are actual values, I can find what they equal. X is going to equal a 4, and x equals a -8. For those of you who need to see it, again, all you do is you're simply going to take -2 plus 6. That gets me the 4, and -2 minus 6, because I had this plus or minus here. And that's your -8. Okay, so that's your first question. Second question, same process. Get your x's by themselves. So I'm going to start by subtracting 121. That is going to get me x squared minus 22x equals -40. My b term, again, repeat that process. It's a -22. I'm going to divide that by 2 and square it. So that's -11 squared, which is 121. I'm going to add that into both sides. That's going to let me do my shortcut of factoring to be x minus 11. Again, that was here. Squared equals 81. And then again, when we go through and we solve using our square root method, we'll be able to get our 2 solutions. And again, remember, we're going to have 2 solutions because when you square root, you have that plus or minus of the value. Okay, so square root of 81 was plus or minus 9. I add 11 to it. So I'm looking at 11 plus 9 and 11 minus 9. 11 plus 9 is 20. 11 minus 9 is 2. Okay, so those are the first 2 questions. Those are your do now questions from today's class. We're going to continue. We did not do 5 in class today, so we're going to do that one now. And then 7 and 9 look a little bit different. We did those also, but I want you to make sure you know how to deal with values that have coefficients. Okay, so I'm going to clear these 2 out. Let's swing number 5 on over. So again, number 5, same as always, get my variables alone. So I'm going to start by adding 5, get that away. X squared plus 8x equals 5. My b term, again, b is always attached to your x. So that's 8 over 2 squared, which is 4 over 2, or 16. I'm going to add that to both sides. I can use my shortcut. This will be x plus 4 squared. 5 plus 16 is 21. And again, from here, I'm going to solve. Now, when I solve this one, it's not going to be as pretty, but that's okay. I have x plus 4 equals plus or minus the square root of 21. If you can simplify your radicals, you can, but there is no perfect square that fits with inside a 21, so I'm going to leave it and just subtract that 4 over. And I have x equals negative 4 plus or minus square root of 21. And that's it. I can't do anything with it because I don't know what the square root of 21 is, and I want to leave it in as exact terms as I can. All right, so number 7. First with number 7, you got to do a little bit of moving on both sides. I have to move 40. And I'm going to do this all at once. I'm also going to move that 28x. Again, you can do it one at a time, but just to save some time, I'm going to do it all at once. So you have 4x squared minus 28x equals negative 40. Okay, so now our issue here is this leading coefficient. I cannot do completing the square if I have a leading coefficient. So I need to get rid of it. And the way you get rid of it is you are simply going to divide everything, whether it is divisible or not. You will divide by this leading coefficient. It just so happens that in this case, they are all divisible. So it works out nicely. But if it doesn't, that's okay. Just leave the fractions in reduced form. Okay, now I'm at this point. Here I can do my completing the square. My b term is a negative 7. So negative 7 over 2 squared. Well, it doesn't divide. I'm going to leave it as that fraction. My negative 7 over 2 squared is 49 over 4, square top and bottom. So I'm going to add that to both sides. Don't let fractions scare you, please. They're not that difficult to work with. Now, this is why knowing your shortcut of factoring is really beneficial. I use my x and I use my b over 2. B over 2 is negative 7/2. I'm going to leave it like that. And then this is going to equal, so for those of you who need to see the side work, I have a negative 10 that I need to turn into a fraction over 4. So negative 40 over 10, negative 40 over 4 is a negative 10. And then I can add to it the 49/4 that I was adding down here, and that's going to get me 9/4. Okay, still work with all this. Square root. When I square root this problem, again, insides are going to fall out. Plus or minus, square root both the top and the bottom. I can do that. They're whole numbers. Square root of 9 is 3. Square root of 4 is 2. And then again, just like always, get your x by itself. So I'm going to add that 7 over 2 to both sides. So I have x equals 7 over 2 plus or minus 3 over 2. I can still simplify these. If I do 7 plus 3, that is 10 over 2, which is 5. That's one answer. Second one, subtract now. 7 minus 3 is 4 over 2, which is 2. So the answer to this problem is x equals 5 and x equals 2. Okay, and our last question, number 9. So number 9 is not set up for anything nice right now. I need to distribute that before I can do anything. So we're going to distribute that 2x into my x minus 2. That's going to get me 2x squared minus 4x equals 200. I don't have to move anything. My x's are already on the left side. They're together. My numbers are already by themselves. So just like the previous problem, I'm going to divide everything by 2 because I got to get rid of this leading coefficient. Anytime I have a leading coefficient, divide it out, get rid of it. So this ends up becoming x squared minus 2x equals 100. Repeat what we've been doing. B term. So negative 2 over 2 is negative 1 squared is 1. So I'm going to add 1 to both sides. Okay, use my shortcut. This becomes x minus 1. That was my b over 2 squared equals 101. I'm going to square root both sides. X minus 1 drops out. Plus or minus the square root of 101. Doesn't reduce, no perfect square there. I'm going to add 1 to both sides. And this ends up being x equals 1 plus or minus square root of 101. Okay. Now, again, solving by the completing the square, probably not your go-to method. You're probably going to choose the quadratic formula or factoring if that comes easy to you, but you do have this option. Now, the main reason we want to know how to do completing the square is so we can transfer a function from standard form into vertex form. So that way we can get the vertex easily and we can graph and find all those pieces of information that we normally need to find. Okay, so that was these two questions. So real quick to go through them, we're still going to use our completing the square the exact same way we always do. We still want to get our x's by themselves. So these two pieces need to be alone. I'm just going to leave the function notation there. Don't worry about it. Just keep moving it along every time you do something. Okay, I'm going to use my b, which is -8. So -8 over 2 is -4 squared, which is 16. I'm going to add 16 to both sides. I say you can't do anything with function notation, so it just gets written. -18 plus 16 is a -2. And this is going to factor to x minus 4 squared. Again, there's my middle term divided by 2. That's what I use for factoring. And then the last thing you want to do is get the function notation alone now. Once I've already completed the square, move everything away so I can have my brand new function, which looks like this. So that is in your vertex form. So just a refresher, that is y equals a x minus h squared plus k, where your h and your k are your vertex. It is an ordered pair, opposite of the inside, comma the number on the outside. From there, I can find all pieces of information that I might need. So in this problem here, my vertex is the point 4, 2. I can then ask you a whole bunch of other questions. I can ask you to graph this. I can ask you if it's a max or min. I can ask you domain or range, all of those things. So just to go through this problem real quick, remember a few things. Your axis of symmetry is always your x value. So it's x equals 4. Your max or min, and this is a minimum in this case because your a value is positive. There's no minus sign in front. So the minimum is your y value. So y equals 2. You separate the two pieces. The domain is always going to be all real numbers. Your range is based off of your minimum. So since it's a minimum, everything has to be bigger than it, so greater than or equal to that value. And then the last thing would be our increasing and decreasing values. So I know my graph looks like this. I know the point. So I have, remember, negative infinity. I have this axis of symmetry at 2. I have positive infinity over here. And when we talk about increasing and decreasing, we want to know if I was to trace it with my pencil, in what direction do I go in? So on the negative infinity side, I'm going down first. So I'm decreasing from negative infinity to the axis of symmetry, which is 2. And then on the right-hand side, I'm increasing from 2 to positive infinity. Okay, so I can ask you all of those things and to even actually physically graph this if needed. Okay, so let's go through one last problem just to practice and get in another one with a coefficient. So first thing, I'm going to move this 1/2 over to get those x's by themselves. So we get y minus 1/2 equals 1/2 x squared plus 3x. So here's my problem, this 1/2 x, or 1/2 x squared. Easiest way, yes, you can divide everything by a half. You're fine by doing that. It's not going to change anything. But you could also, anytime you have a fraction, remember you can multiply by the reciprocal, which may make life a little bit easier. So I'm going to multiply everything by 2/1. Everything. Just like we divided everything before in the previous problems. So this becomes 2y. 2 over 1 times the negative 1/2 is a negative 1. 2 over 1 times 1/2 is the positive 1 that we wanted. 3 times 2 over 1 is 6. Okay, from here, there's my b value. So 6 over 2 and square it. So 3 squared, which is 9. So I'm going to add 9 into both sides. I get 2y plus 8 equals x plus 3 squared. Again, shortcut, use this. Now we got to move stuff back over to get my y by itself, so it's a function. So we move that 8 over. We get 2y x plus 3 squared minus 8. Now, in the previous problem, we stopped because the function was already alone. Here, my y is not alone. I need to get it completely by itself. So I'm going to divide everything by 2 yet again. You could also multiply by the reciprocal like we did previously if you wanted to. But you will get y equals, this you can keep either as the fraction x plus 3 squared over 2, or it is actually simply 1/2 times that. And I'll tell you the reason why I change it in a moment. And then 8 over 2 is 4. Okay, from here, just like previous problems, I can get my vertex. So the vertex is -3, opposite of the inside, and -4. Axis of symmetry is your x value, so x equals -3. This is a positive 1/2. It's a positive a, so that tells me I have a minimum again. So it's a minimum at y equals -4. Domain, all real numbers. Range, y is greater than or equal to -4. Again, it works off your minimum. It's a minimum. Everything's going to be bigger. If that was a maximum, everything would be less than. And with our increasing and decreasing, again, I know it visually is going to look like this. I know my axis of symmetry is at -3. I have negative infinity on the left, positive infinity on the right. So I am decreasing first again, right? It's going downward from tracing it, downward from negative infinity to -3. And then it increases on the other side, negative infinity to positive infinity. Okay, so again, I could ask you any of these sets of questions, one or all of them, and I could also ask you to graph it real quick. If I asked you to graph this by hand, right, if I had my coordinate plane here, 1, 2, 3, 4, I would plot my point, my vertex, so -3, -4 is here. I have my axis of symmetry, and I can use that 1/2. I can go up 1 and out 2 on both sides by using this 1/2 kind of as a slope. It's not really, but I can kind of use it that way. Oops. And I can come up with my quadratic that way. Okay, so hopefully this cleared anything up. Obviously, if you have more questions, come to office hours, email me, ask me.